Let us see about the introduction of backtracking. So, backtracking is a systematic method for searching one or more solutions for a given problem. Backtracking uses brute force approach and it is not an optimization problem, whereas in dynamic programming it gives the optimal solution for a given problem. So here in backtracking it finds all possible solutions and represent the solution in the form of a state space tree. So let us see the types of problem that can be solved by the backtracking technique. The first one is the enumeration problem, where it finds all solutions for a given problem. Second is decision problem. Here the solution is given in terms of yes or no. Third is the optimization problem. Here the optimal solution is found out which maximize or minimize the given objective function as per the constraint of a given problem. And now let us see about the basics of backtracking. So in backtracking, for the first main thing is about the constraint. So constraints will tell about the rules that restrict the generation or processing of a tuple. And the second one is a bounding function or validity function that will tell about the constraint of a given problem. And there are two types of constraint. One is the implicit constraint, which limits the generation or processing of a solution vector that will maximize or minimize, or it satisfies the criterion function. In explicit constraints, these are the rules that restrict the component of a solution vector. Say, if xi has to be greater than 0, then it can take up a value only which is greater than 0. So this is about the implicit constraint and the explicit constraints. And next, let us see about the stages in backtracking. There are two main stages in backtracking. First one is a generation of the state space tree, or I can call it as to be as a recursion tree. And second stage is about the searching of state space tree. So in the first step, we arrange all possible solution in a tree-like fashion that we call it as the state space tree, and this can be as a fixed tuple tree or the variable tuple tree, and the nodes of a tree will represent a partial solution, and every edge will represent the transition from one state to the other state. And there are three types of nodes in the state space tree. One is a live node, second is the E node, and third is the dead node. So the live nodes are the nodes that has been generated but yet to generate a children. And E node is a node which is under consideration, and dead node is a node which cannot be considered for further searches. And the second stage in backtracking is the searching in the state space tree. And backtracking uses the depth first search, and hence it is called as a refined depth first search algorithm. And here there are two types of nodes that backtracking can define. One is the promising node and the other is the non-promising node. The promising node will lead to a final solution, whereas a non-promising node, from the non-promising node, a solution can't be expected. And there are few applications of this backtracking. The first application is n-queens, and second one I can quote as the sum of subset problem, and third as graph coloring. So we'll see the rest of the applications in the forthcoming lectures. Thank you for watching.